So in this video we are going to look at shifting the graph of f of x given its plot in 4 points based on all these transformations. So we have a lot going on in this one here. The 2 on the outside is going to be a vertical stretch by 2. The 2 on the inside is actually going to be a horizontal compression, and now it's opposite of what we expect, so it's actually not by 2, it's actually by 1/2, because it's actually going to squeeze the graph in. This 3 is actually going to be a shift left, but it's actually not going to be by, it's not going to move the whole graph left by 3 is what we're going to find, because the horizontal compression gets applied to it too. It's actually a shift left of 3 divided by 2, so 3/2. Finally, we're going up 1. So we have 2 things going on the y values, 2 things going on the x values. And we're going to look at how we can figure these out. So I'm going to show you how you can actually calculate them so that it's not quite as tricky. So let's talk about moving this point, -3, 2. What's happening with the x values, because that's a little tricky, is we're saying, okay, what's the new x value such that 2x plus 3, because that's what's happening inside the parentheses, equals the old x value. This is the new x value. So what we do is to solve this is, first off we subtract 3 off of each side, and we get 2x equals -6, and then we divide by 2, and we get x equals -3. I know it doesn't look like it moved anywhere, but we'll see that the graph has been shifted. So the x value for this one is -3, and that's why, notice, because it gets divided by 2 after the move left, that's why the horizontal compression is also applied to the shift. So there's our x coordinate. Our y is a little more straightforward. A vertical stretch by 2 means we double it. Up by 1 means we add 1, and we go order of operations. So we know the x value will be 3. We take the 2, we multiply it by 2 is 4, add 1 is 5, so this point becomes -3, 5. So -3, 5. Maybe draw an arrow just to show that that's that point. So remember what we do to the x value, because I'm not going to go through this part again, but I'm going to basically do the same thing. To do my x value, I subtract 3 and divide by 2. So I'm going to go from 0, I'm going to subtract 3, so that would be -3, and divide by 2, so -3/2. So -1.5 is my x value. My y value, I double it and add 1. So that's going to be doubled is 8, add 1 is 9. So I have -3/2, 9, which is going to be way up here. So -3/2, 9. Alright, so there's that point. Next point, we go to 3, 0. And what we do to the x, subtract 3, cut it in half. So subtracting 3 makes it 0, cutting it in half is going to keep it at 0. So it's a nice easy x value is going to be on this point is getting moved to the y-axis. The y value, if we double 0, is still 0, because a stretch, it basically looks like it's pulling things away from the x-axis. And then adding up 1, this actually just becomes the point 0, 1. So we got 3 of our points moved. We only have 1 more to do. The 6, remember what we do to the x. We subtract 3, cut it in half. Subtracting 3 would move it to 3. Dividing by 2 would move it to 3/2, or 1.5. So we're over in here somewhere. The y value, remember it's getting stretched, so it doubles first. So that'd be -4, and then up 1 would be -3. So we have positive 1.5 for the x, and -3 for the y. So we have the point 3/2. -3 gives us our 4th point. So if we look at our graph, as I plot this, sorry, wrong line. Got confused on my points. So we have a line here, I have a line here, and I have a line here. Now we can kind of see all that stuff happening. We can see the stretch vertically, it's being pulled away from the x-axis. We can see the compression horizontally, it's being compressed towards the y-axis. We can also see the shift left as all these points have been moved just a little bit left. So that's how we can handle when we have a whole lot going on at once.